Hi everyone. In this lecture we're going to talk about using Excel to create frequency distributions, graphs, and calculate a few descriptive statistics. Everything that we're going to talk about in here today will be what you will use for the first data analysis assignment. That's part of this week's content. I'm going to be switching, so in this presentation I'll be switching back and forth between this PowerPoint presentation and then some sample Excel data, which I've got open already. I've also posted that in UB Learn, so you can sort of follow along if you like. All right, here's what we're going to be doing. We'll talk about frequency distributions, graphing, descriptive statistics briefly, and then we'll just talk through the review assignment, or we'll talk through the assignment in a form of review. Just again as a reminder, everything is in this week's module. Note that the data that we're using as sort of an example for this lecture, and the data that you'll use for the data analysis assignment should actually be data analysis assignment number 1. Note that data is actually, they're different data sets, but they are all in the module, and they should be labeled pretty clearly for you. So first thing we'll talk about is the frequency distribution. And if you remember from last week's lecture, we talked about the absolute frequency of values in a variable. We talked about the cumulative frequency and then converting those to percentages. Remember that there is a difference between sort of a frequency distribution and descriptive statistics. We can run a frequency distribution for data that's at the nominal level and data that's at the ordinal level. We can calculate descriptive statistics for data that's at the interval and ratio level data. And just to orient you to everything, there is a codebook in this week's module as well, and I'm going to show you that here in a second. So let me switch over to Excel first, and then we'll switch over to the codebook, and then we'll start working with a little bit of syntax here. Okay, so here we've got the Excel file open. For whatever reason, I was on the Data tab. I should be on the Home tab. There we go. So there are, remember we talk about, rows here and columns that sort of go up and down. So each row represents a different person. So this first person, for example, their case ID is 100, their age is 72, their gender is 1. We don't know what that means yet because we haven't checked the code book. Whatever this variable is that's called edu3cat, this person scored a 1. Again, we don't know what that is because we haven't checked the code book yet. And then whatever this CSE_TTL variable is, this person scored a 60. And again, we don't know what that is because we haven't checked the code book. We will here in a second. So there are... if we scroll down, we can sort of get a sense of how big the data file is. It looks like there are 83 people in the data set since we started with the case ID 100. We get up to 182 there. I don't know why we started with case ID 100. There's different reasons. It's probably a good idea to exclude sort of the number 1, that kind of thing. But obviously we've got a number of people in this data set, a couple of different variables on them, and let's check out what it is they mean real quick. Okay, so this is that code book. We talked about code books a couple of weeks ago. We talked about all the different columns and things like that are in there. So that case ID variable is just a unique identifier for each survey. As we saw, it goes from 100 to 182. It's obviously a nominal level variable. Age, pretty self-explanatory. The question was, how old are you? The range was 60 to 89, and this is an interval or ratio level variable. Gender, so the question associated with that variable was please indicate your gender. And 0 is coded as male and 1 is coded as female. So if we remember back on this first row of data here, this person had a 1. So this would be a 72-year-old female. I'll just go back to the codebook here for a second. So now we can figure out what this edu3cat variable means. And the question associated with it was, please indicate your highest level of attained education. 1 is no degree, 2 is coded as a high school degree, and 3 was coded as a college degree. So this first person here is a 72-year-old woman who has no degree. And then we can figure out what this CSE-TTL is here. And so that variable refers to a question that probably was a computation of a computer self-efficacy score. Self-efficacy is just your belief in your ability to do something. So this probably relates to a person's ability to do all of the things that he or she needs to do on a computer. So this particular person, that first case we were looking at, 72-year-old woman, no degree, and her computer self-efficacy score was a 60. Again, you've got the variable levels over here that you can refer to. By the way, you do have this for the data analysis assignment as well. So you're going to want to refer to the codebook to figure out what the different variables mean and what the different levels of measurement are. So I'm going to go back to the Excel workbook here, and we're going to figure out how to work with this data a little bit. So first thing we will do, let's start with the age variable. Okay, so we know that the age variable is this is an interval or a ratio variable. So we could look at a mean, we could look at the median, we could look at the mode, and we could look at the standard deviation. I will show you how to calculate all of those here in a second. So let's do that here. So remember in Excel, when we want it to perform a calculation for us, remember that the sort of generic formula for a calculation is the equals sign, and then whatever the function is that we want to use, and then parentheses, and in those parentheses we put the array. The array is the range of cells from which it's doing its calculation, or it's drawing the data for the calculation. So what I usually like to do, just to stay organized, is I usually write down on a scrap of paper, off to the side, the array that I'm working with. And so if we're working with this age variable, the array is going to be cell B2, right? Because we name cells based on their position. So this one is in column B and it's in row number 2. And it ends at cell B84. So the array that we're working with is B2 to B84, and we separate those two cell names with a colon. So I'll show you. We'll do the first thing here. So first thing we'll calculate. How about the average for age? Now the other thing I do to sort of keep myself organized is usually in an adjacent cell. I will type out what it is I'm calculating in the next cell. So I would write something like average in this particular cell, and then I would write the formula for average here. And the formula for average always starts with equals, and then it's the word average, and then simply the array from which Excel is drawing the data, and that array is B2 to B84. We close the paren, and you hit enter, and we can see that the average age here is 71.78 years old. Now we could also calculate the median and the mode. So I usually do that, you can sort of do that wherever you like. This is merely my preference to do it sort of underneath the column that I'm working with, but you could do it somewhere else. So I would label median here just to sort of remind me that that's what I'm putting in this column here. And then the formula for median is equals the word median. And then again, it's that same array that we used before, B82 colon B84. Hit enter, it does its thing, and we get the median. In this case, the median is 72, which is actually pretty close to the average. Lastly, we can calculate the mode, which I will write in this column just to remind me what it is I've done. And then, oops, I typed that wrong, equals mode, and then parentheses, B2 to B84, close paren, hit enter, and the mode happens to be the same just about as the median and the same as the average. All right, so there you go. There are other descriptive statistics you can run. If you wanted to calculate the standard deviation, for example, you can label that and then type it out. In this case, standard deviation is actually a sort of an abbreviation of standard deviation. It's STDEV, but same thing. It's the command followed by the cells from which Excel is drawing the data, and you hit enter. So in this case, the standard deviation is 7.08. That gives us some idea of the way the data are distributed there. So okay, so next thing we could do. So that's what we've done here with a ratio or interval variable, but we should work with a nominal or a sort of categorical variable here. And gender is a categorical variable, so we can calculate, if we want, the number of ones and the number of zeros. All right, so if we remember back from this code book, 0 is coded as male and 1 is coded as female. So what we're interested in doing is sort of going through and calculating or counting, if you will, the number of ones and the number of zeros. Now we could do this by hand. It would be pretty tedious, and frankly Excel can do it for us. So we might as well ask Excel to do it for us. So again, this time we're not working in column B, but we're working in column C. So on my little scrap of paper off to the side here, I'm going to write the array that we're working with, which in this case is C2, down to cell C84. Okay, and so what we want to do is count, we'll count the zeros first, and referring back to our code book, the zeros are males. Oops, that's the PowerPoint presentation. Let me switch back to it. Okay, so here we are back in Excel. Actually, I accidentally switched to the PowerPoint presentation there. So what we want to do is count the zeros. And again, I just like to label things just to the left of the cell that I'm working in. So I'm going to put that label here. And in this case, I'm going to write male, and I'm just going to put a 0 in parentheses, just to remind me that in this data, male was coded as 0. So here's how we do this. This time we're not going to use any of the average or median or mean median mode functions. We're going to use something different. We're going to use a COUNTIF function. So our formula always starts with the word, or starts with a symbol equal. And then in this case, we're going to do a COUNTIF function, and that tells Excel that we're going to count all of the instances in an array with some condition that we specify. So the formula is COUNTIF and then open paren, And in this case, we want it to count the 0, so we put that in first, followed by a comma. Oops, I'm sorry, we do the range first. So we do C2 to C84, and then what we do is we tell it the criteria to count, close paren, hit enter, and there are 20 men, or 20 zeros. There are 20 instances of 0 in array C2 to C84, and that's what this is returning. Next, we want to count the female. Oops, I spelled that wrong. The female, and in this case, remember it's a 1. So this time we're going to use the same formula. Instead of a 0, instead of it counting zeros, it's going to count the 1s. So same thing, equals count if the range, which is just another word for the array. I think they updated range and array at some release of Excel here. The range here is C2 to C84, and this time we're telling it to count the 1, all of the 1s. So close paren, hit enter, and we see that there are 63 women in this particular data set. And again, if we wanted to, if we had the interest, we could go through and count all of our work, or we could double check our work by counting. The other thing that we could do is simply add these up, right, and figure out if we inputted the data correctly or inputted the formula correctly or something like this. One of the shortcuts we could take real quick if we wanted to is just to add up these two numbers, and in this case we're adding up the array C90 to C91. Right, we're just adding those two numbers. It tells us that there are 83 people in the data set, which we know from the number of rows in the data set. So in this case, we can be confident that our work is correct. All right, so let's do the same thing with the edu3cat variable. Let's remind ourselves what each of the three categories stood for. And so we'll switch back over to the code book real quick. And so 1 stands for no degree, 2 stands for high school degree, and 3 stands for college degree. This is an ordinal level variable, so we can do frequency distribution with this. We can't do anything else with it. We can't compute a mean, a median, or a mode. But we can count the number of times the 1 appears, the 2 appears, and the 3 appears. And so let's do that real quick. So again, same thing I do over here. Actually, the first thing is just I make a note of the array that we're working with. The array in this case is D2 to D84. And again, I like to label the cell just to the right. Just to the right over here. If you make a mistake, you can fix it. If you don't like how the cell sort of spills over into the other, you can make that column a little bit bigger if you want. Again, these are all things that you can do, just sort of personal preference, whatever makes it easier for you. So same thing. We're gonna count. We're going to count the number of 1s here. So remember, our formula for that is count if. We simply input the range of cells from which the data are drawn. In this case, it's D2 to D84, and we're counting the 1s. We have 24 people who have no degree in this particular data set. Let's count the 2s. The range is D2 to D84. comma space 2, close parenthesis. There are 22 people with a high school degree. And then let's count, let's count the people with a college degree. Count if the range is D2 to, goofed up there, D2 to D84, and this time we're counting the 3. 37. So we have 24 people in this data set without a degree, 22 people with a high school degree, and 37 people with a college degree. Let's double check our work and make sure we caught everyone or didn't make a mistake. We can add these 3 numbers up. So we're adding cell D94 to D96, and there are 83 people, right? So there are 83 people, just like there were 83 people in the gender category, so we know we did something correct there. Okay, so if you remember from the lecture for last week, one of the things that we can do with categorical and ordinal data like this is create graphs, so we can visualize these data, and we could use a pie chart for this. We could use a histogram. Remember, the most appropriate chart sort of depends on the data and the point that you're trying to convey. So why don't we make a pie chart with the gender data, and we'll make a histogram or a bar graph with the education data. So let me show you how to do that. If you remember if you remember from the single system design lecture, the way we create graphs is we highlight the information we want to graph. We go to insert, and then we tell it which kind of chart we want to make, right? So I'm on a Mac here. The screen should look pretty similar if you're on a PC, but you just go under the insert chart, and then you go to the pie chart. You could do a 3D pie chart if you want, it's your call. And let's click on that, see what happens, and sort of put it behind me, but oops, here we go. Here we can see it's pulled the labels directly from this category of labels over here. That's part of the reason why I like to label my work, because it actually makes making charts a little bit easier. It's sort of randomly assigned the colors red and blue to it. That probably has something to do with the default settings on my computer. Yours might be different. You know, any color is fine. Grayscale or something like that is fine as well. You can change colors in this if you wanted to, whatever sort of appeals to you. Now you'll notice that in the legend down here, it actually included, oops, made that a little too big. It actually included the 0 and the 1. If you don't like that, for whatever reason, you can go over here and you can actually delete that 0, and it will automatically update it for you on the chart, just like that, right? You could add a chart title in here, delete the words chart title. Call this, sort of whatever you like. But again, I'm just using sort of Excel's built-in labeling functionality here. This is called a legend. You can change where the legend is. You can put it on the right if you wanted to. It was on the bottom before. I think this kind of stuff is sort of up to your own discretion, whatever you like. So okay, that was making a pie chart. Let's make a bar chart out of this information here. Okay, so again, process is pretty similar. We highlight the information that we want to graph. We go to insert. This time we use a a vertical bar chart. And in this case, we want a clustered column, not a stacked column. But here we go. This tells us, computer's acting wonky. All right. So this tells us how many people have a no degree, a high school degree, and a college degree. Again, if we wanted to take the one out of there because we didn't like the way it looked, we could just go through and update things. If you wanted to change the color, you could. Again, this is a good chart for these data here because there are 3 categories, and we can sort of make a guess about how many people are in the study based on adding these 3 kinds of things, or adding the tops of these 3 charts up here. So we might add the number 24 or 25 to 22 or 23 to whatever that is, 36 or 37 there, and we would get to 80 some odd people there. We don't get that same information from a bar graph. Remember, we get the proportion of people who are, a pie graph. We don't get that same information from a pie graph. We just sort of get information about the proportion of males and females. We don't get any information about the total number of males and females. We would get that in here. So again, that's why it's sort of a good idea to experiment with different graphs and think about what message it is you're trying to convey with your data. You may have noticed that in the insert category, or in the insert tab up here, there is this thing called recommended charts. I've not ever really had any luck with it. That doesn't mean that you can't use it. Like I said, I've just never had any luck with it. The sparklines thing, you can ignore that. We won't be using that. Like I said, my preference is just to go to the sort of chart that I'm interested in making. I tend to ignore the recommended charts feature. Okay, so a couple other things I was going to show you in Excel real quick. We've calculated all of the descriptive statistics for this age variable, except for one, and that's the range. I'll show you how to calculate the range here in a second. You could practice calculating those same descriptive statistics on this computer self-efficacy total variable if you wanted to. But let me show you real quick how to calculate the range. So Excel doesn't have a range function. What it actually has is a min and a max. And from the minimum function and the maximum function, you can calculate the range. So let me show you how we do that. So the first thing I do is label the cells adjacent to it. I do min and max in that order. You could do max and min in that order if you wanted to. It's completely up to you. And then the formula for min, or the syntax for min, the minimum number is simply min, and then the array. And this time we're back in array B2 to B84, right, paren. The minimum in this case is 60. We could probably check that just by scanning the data if we wanted to. I found a 61, haven't found a 60 yet. There it is. So the 5th one down is a 60. And then the max function, same thing, except instead of typing min, we type max. And the array that we're drawing from here is B82 to B84. 89. All right, so if we want to calculate the range, right, which we'll just do in this cell, for example, the range is simply the max minus the min. So we could do this a couple of different ways. We could do a calculation, like a syntax calculation in here, which would simply be 89 minus 60, right? That's going to give us 29. We could, if we wanted to, we could just write out that the range is 60 to 89. That would be fine as well. We could also just tell it which cells to subtract. So that would be equals cell, what is it, B90 minus cell B89, right? So it's just subtracting 60 from 89. Like before, we're going to get 29, right? So the range in this case is 29, but it extends from a minimum of 60 to a maximum of 89. So let me switch back to the PowerPoint presentation for today, or for this week. This is now what a table would look like if we were writing this up for a paper or something like that. We've calculated all of these different things, so we could calculate the n here, right? The n is simply the sample size. We could calculate percentages from this. We will back up. I'll show you how to do that in a second. But we've calculated the mean, the standard deviation, and the range for age. You could do the same thing for the computer self-efficacy if you wanted to. We'll calculate percentage here in a second. Same thing, for gender and highest degree of education. So let me switch back over to the Excel file and we'll do percentages real quick. We'll calculate just an absolute percentage real quick for each of these. Remember from last week, the formula for percentage is simply the proportion that answered some way in a variable divided by the total number of people in the study. So what's the total number of people in the study? We actually answered that before, but I erased that cell. The total number of people in this particular data set is 83. If we wanted to figure that out again, we could just add these two cells together, right? We would get 83. This is actually convenient to do sometimes, and I'll show you here in a second. So let's say we want to figure out which percentage men are or males are in this particular study. We could just put that in these couple of cells right here. In this case, the percentage of males would be, or to calculate the percentage of males, we would take 20 and we would divide it by 83. So we would put equals. We would put in this cell. In this case, we're just going to click on it and save a little bit of time, but we're going to divide it. In that case, in this case, the dividing or the command to divide is the forward slash. And we're going to divide that by 83. So we're dividing 20 by 83. We could do this by hand if we wanted to, but we'll see what Excel gives us here. And in this case, what it gives us is 0.240963855. Okay, that's very nice. We'll convert that to a percentage here next. Remember that a percentage is nothing more than a decimal, and a decimal is nothing more than a fraction. If we're not using the percentage sign itself, what we're going to get is a decimal. And if we want to convert this, or if we want to have Excel convert this for us, what we can do is simply change the format of the cells, right? So in this case, what we're going to do is go to format cells. We're going to tell it that this cell actually is a percentage. We can use 2 decimal points if you want. You could use 3 or 1 or whatever. Change that, and here it rounds it to 24.10%, right? So men or males are 24%, a little more than 24% of the people in this study. We could do the same thing with the number of females, right? So that would be 63 divided by 83. And in this case, the decimal we get is 0.759 and change. Again, we could just convert that or change that to a percentage by telling Excel that this is a percentage. There we go. And if we really wanted to, we could check our work, right? You can sort of see that 75.9 plus 24.1, if we were to add those two variables up, or values up, we would get 100. We can do it just just for the heck of it if we want to, right? Oops. Let me redo this. I don't know what happened there. Do this again. Right, so if we were to add those two up, it adds up to 100%, which is what we would expect it to be. And if we remember, now I did delete the pie chart here, but I could put it in real quick if we wanted to. Again, pie chart. Right, so this corresponds to roughly what we get on the pie chart. Right, women are about 75% of respondents to this particular study, and that's sort of what this is telling us, right? A little more than 75%, and males are about a quarter, a little less than a quarter of the people in the study, and that's sort of what this pie chart is telling us here. Okay, so let me tell you what we're looking at now. This is a new Excel file. This is the data for the data analysis assignment. There are far fewer cases. There's only 20 people in this particular data set. However, there are more variables, right? So there's a few more variables, but much fewer people. Reason for that, it gives you a little bit more to work with, but there are fewer people, so you could calculate things by hand if you needed to. You could double check your work. Okay, let me show you what the assignment looks like real quick. So this is just the Word document with the assignment. Let me just move myself so we can read through it real quick. So we're going to use Excel to calculate descriptive statistics for each of the variables in the data set, and that excludes job title and case ID. Right. So what you calculate is going to depend on what kind of variable it is. More on that in a second. And we're going to create a pie chart for the variable BSW. We're going to create a bar chart for the variable area. And then in a Word document, you're just going to write a brief memo about what it is you've found. So this is the code book for all of the variables in that Excel file. This is up on UB Learns as well. So you can figure out what all of these different things mean. And again, I want to draw your attention to the level of measurement over here for each of the variables. Remember that you can use this to determine what it is you need to calculate for each of the variables. Okay. So this code book is up there, and then let me lastly show you what the memo looks like. All right, so this is just an example of what a memo would look like. You can leave out this part if you want to, but really this is just a couple of sentences about a couple of the different variables in there. You can follow this format on there. Next week there'll be a lecture on inferential statistics, and then we'll conclude with calculating those inferential statistics. So any questions, as always, feel free to get in touch with me. Thanks.